So, like I said, I'm okay, thanks. We looked at the quadratic, and from the quadratic, we got this sideways parabola, which I told you was kind of the square root function. But the interesting thing was that because it's not a function, because if I do the vertical line test, it touches 2 points, we had to do something to it, and we had to what we call restrict the domain. And so just really quickly here, I want to just show you this again, and if you can draw this, you can. But remember how we started off with the parabola? And what I wanted you to show you is this. If we just took half of the parabola, okay? So this is the case where the domain is bigger than or equal to 0, okay? And I asked you to find the inverse, okay? What you get is you get this part of the square root function, which is the top half, or the positive root x, okay? Whereas if I were to take the other half of the parabola, so if I were to take the left side, okay, the equation's the same, y equals x squared. In this case, the domain is less than 0. What was the result when I take the inverse? Anyone remember? You get the sideways parabola, but which part? The bottom part, right? So now what you have is y equals to root x, but it's the negative portion, okay? So what I'd like us to do today forward is I want to focus on this function here, what we call the square root function. I want to show you some basic characteristics, and then we're going to do some stuff. Remember that stuff? Yeah. Yeah. So I'm going to do all that stuff with you again. All right. Okay. Yes, for those of you online, we'll do some dancing again. Okay. And the reason why I want to do some more dancing again is because in chapter 12, oh no, so in grade 12, your first chapter of studies in math is all about this transformation and graphing stuff. So I'm hoping that today I can kind of preview all of chapter 1 for you. All of chapter 1. Okay? Yeah. Let's go. By the way, this stuff's not on the test. Here we go. Let's look closely at what I call the basic radical function. So like my examples of chips, this is regular chips, okay? No flavors, regular chips. Okay, boring regular chips. Regular's the best. Okay. Anyways, look at the graph. Here's y equals root x. Can you tell me where the left endpoint of the graph is? What's the leftmost point of this graph? 0, 0. Good. Write it down, please. The leftmost point is 0, 0. And what's the right endpoint? It goes on forever and ever. Yeah, so really we don't know what it is. If you want to use the idea of infinity, then write down, sure, infinity, infinity. Okay, that's fine. Now, remember how we talked about lines? Lines were lines. Parabolas were what we called the U-shaped graph. Well, what do you think I want to call the shape of this graph? Curve. Yeah, it's a curve. What kind of curve? Maybe I'll say it's this. I've been telling you sideways parabola, but yeah, it's actually half. So okay, half of the sideways parabola. Now, maybe I didn't be more specific. I heard someone say the word upper. Yeah, so I think maybe I should say upper half of the sideways parabola. Okay. Yep. Well, on right endpoint, when I talk about infinity, infinity, that means my x value is really big, infinity over here, and my y value is also really big. So this graph kind of goes up, 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 up like this forever. Okay? Like a rainbow that never comes back down. Now, we talked about these things called domain and range, and I want to talk about them again. So what do you think the domain of this regular basic graph would be? Larger than what? Is it just larger than 0? Can it equal to 0? Good. So x is greater or equal to 0. Now, for those of you like the formal way of writing domain, we have those curvy brackets with an x with a bar. X is greater than 0. I also should say x is all real numbers. But once again, if you just give me this part, I know what you're talking about. Okay. And how about the range? Same thing, except instead of we call x, we use letter y, right? So the range, notice all the values of y are bigger or equal to 0 as well. Good. Okay? This is the regular radical function, y equals root x. Let's see what happens when we do these transformations. So now let's put in some flavor. Let's put in some ketchup. Let's put in some barbecue. Let's put in some salt and vinegar and sour cream and mustard for chips. Okay. Anyways, the first investigation or the first flavor we'll put in is this. Notice I've got y equals root x, and now I've added this plus 3 at the end. So my question to you is, let's make a table of values, answer the question about the y-intercept, and graph it out. How about these particular values? Let's make life easy for you. 0, 1, let's not do 2. What's the next easy root? 5? What do you mean 5? 4, yeah, root 4. And then the next one? Well, let's do 9. Okay. Okay, ladies and gentlemen, can you go fill out the actual table here, graph it out on the grid to the right, and then answer the question, what do you notice about the y-intercept? And this should be very familiar to you all, I hope. 3, 4, 5, 6? Sure. 3, 4, 5, and 6. So did you graph it out as well? 0, 3, 1, 4. Now at 4, sorry, that's 2. Yeah, thank you. 1, 4, 4, 5, 9, 6. So there's your graph. Y equals to root x plus 3. Okay. What happens to the y-intercept? Well, you guys all know this. Went up by 3. What about the one underneath? Okay, by the way, if you finish this one, you shouldn't just be chatting. You should move on. So if I were to give you the same x values, 0, 1, 4, and 9, what are your new y values for this particular curve? Negative 1, 0, 1. And the last one here, please. Anyone know? 2? Yeah. 0, negative 1. That's down here now. 1, comma 0. 4, comma 1. 9, comma 2. Okay. Okay, so notice what we did with this one. Okay. The y-intercept goes which way? Down by 1. Okay. Now, have you seen this box before? I just cut and pasted from my previous notes.
Which box?
Have you seen these boxes before? Remember chapter 3 notes? Ooh, that's kind of cool. Remember chapter 3? You never seen those? I will show you that you are wrong. See, look! The box, the box, the box. Everything about a box must be important. So what do we know about comparing the regular function with this thing with a plus k on the end now? Which way does the graph move? Vertically. Thank you, Hisham. And notice if k is greater than 0, which way does it move? Up. And if k is less than 0, it goes down. So what I want you to understand, okay, and ladies and gentlemen, this is important. You know how at the beginning of the year we did quadratics and I showed you the shifting stuff? Now I'm doing the same stuff with a different graph, but look, the concepts are still the same. Okay? Guys, okay? When you get to grade 12, you'll be looking at different functions, cube root functions, absolute value functions, and you'll be doing the same thing, shifting them left, right, up, and down. So these concepts are the same. We're just going to apply it to different functions. Okay? So even with the next investigation now, if I asked you to do this, how would you graph using a table of values? Well, let me ask you this question. Is there a restriction on this graph, by the way? Yes, you should remember restrictions from before. Okay? What is your restriction from this one? X is greater or equal to 4. Great. So if you're going to make a table of values, don't start at 0. What value should you start at? 4. Good. How about 4? How about 5? Now, once again, be strategic. Okay, if I chose 4, 4 minus 4 is 0. The square root of 0 is 0. If I chose 5, 5 minus 4 is 1. The square root of 1 is 1. What's the next number I want? I want a 2, right? So it's nice and easy to graph. So what must my x value be so that this equals to 2? 8. Good. 8 minus 4 is 4. The square root of 4 is 2. Excellent. Okay. And then if I wanted a 3, then I think the next one would be 13. Good. Okay. So go ahead now and graph this out, and let's see what happens. And the question is, what happened to the x-intercept? I guess you can't graph 13 and 3, but whatever, it's there. Okay. Oops. Okay. So I'd like you to now try this, please. What do you notice about the x-intercept? Then, if you're done that one, try graphing the next one underneath. Okay, this stuff is. What do you notice about the x-intercept? Which way did it move? Right. 4 units. Okay. Now, start the next one for me, please. What's my restriction on this graph here? What's my restriction here? X must be what? Greater or equal to -2. Good. So what value do you want me to start with? How about -2? Yeah. That would be 0. I think -1. I'll try next. -1 plus 2 is 1. Square root of 1 is 1. And then I guess the next one's kind of tricky, but can someone help me out? It's 2, yes. What's the x value? That gives me 2. 2. Oh, yeah, 2. Okay. 2, 2. Yeah. And then the next one after that, 3, 7. Sure. Okay, so once again, just graph these out, please. And for those of you who are thinking, I've done this before, I know. Yeah, I know you know. That's good. Okay, but you get a graph that looks like this. And I hope you can understand that the x-intercept did what? Left how many units? Left 2 units. Good. Okay. So give you some time to think about this. And I'm also going to ask you, see if you can fill out the box underneath now, please. Okay. I said y equals to root of x minus h. Okay, be careful, x minus h. That makes a difference. With y equals root x. And which way does it move? Well, yeah, right and left, but let's write down the word horizontally first. Now here's the key. If the h value is bigger than 0, the graph moves left, right, I don't know, right? Now let's think about this. H is greater than 0, so I'm saying y equals something like this. X minus, and this h value here is bigger than 0. So let's say that's 4. Okay, well, hey, that's the one we did up top. So that means it goes right. Yes, this is the one where everything is backwards, remember? You think minus is left? No, it's actually right. Where if h is less than 0, that's like this case, x minus -2, because the two negatives now become a plus, right? So in this case, it goes to the left. Make the distinction, okay? Now, let's see if we can combine this graphing stuff with the idea of inverse to kind of put them together, okay? I'm going to ask you, please, in this case, to find the inverse of these two more interesting functions. Does anyone remember from last day what we do to find the inverse algebraically? What? Well, how'd you get that, though? What are our steps? Switch to the x and y. Good. Remember f of x is y, so we'll switch. X equals to y squared minus 4. Okay? Now, what's our next step after switching x and y? No. What would you do after that? Solve for y. Okay? Okay, let's keep the noise down, please, all right? Okay, so we'll solve for y. So I'm going to move the -4 to the right-hand side. X plus 4 equals to y squared. And then what are we going to do? Going to take the square root. Now remember, when you take the square root on both sides, there's the plus or minus. But in this case, I want you to be aware. Do you see this restriction up here? Do you see the restriction of the domain? To be x is greater than or equal to 0? Well, what does that mean with my plus and minus then? It's supposed to be which one? Positive. Good. Remember, x is bigger than 0. That's the part that's to the right of the y-axis. So when you do the inverse, sorry, you get the actual square root. That's the top portion. So can you please make a note here? Because of the restriction domain of x is 0, we keep the plus part only. Okay? So therefore, your inverse function is actually the square root of x plus 4. Because I put the restriction on there up top. Okay? So I said that, I gave that to you in the question. All right, and let me just quickly show you how to graph this one out. I hope you remember how to graph quadratics. Remember x squared minus 4, you've got this value of the vertex at 0, -4. And then if you plug in 1, you get this and that. So here's the graph of y equals to x squared plus 4 with the restriction. Ugh. Sorry. Okay. And I also want you to graph out the corresponding square root function, which is the inverse. That would then be this one, x plus 4. So you're doing the one that I just graphed above. So I'm going to try to quickly do that for you here. Okay. And I hope you can see how they are related to each other. Okay. I'll do one more thing for you. Remember, for inverses, we're taking a reflection in this line. Okay. So I hope you can see that the half of the regular parabola, when I reflect it, gives you the sideways parabola. Okay. The idea of doing the inverse is this. All you need to do, first of all, is switch x and y. Okay? X equals to y minus 3l squared. That's all you need to do. And then what was the next step? Solve for y. Now, you might be a little bit weird solving for y here, yes, but nonetheless, it's the same idea. What should I do first to get rid of the square? That's right, we'll take the square root. Okay? Now, technically, I guess there should be a plus minus. We'll deal with that in a second. Right? What's my next step if I want to solve for y? That's right, just plus 3. 3 plus or minus root x. There you go. But once again, because we have this restriction of x is bigger than 3, which half am I keeping? The top half or the bottom half? The top half, right. So this is the same thing as 3 plus root x. And therefore, the inverse is equal to, and I'll rewrite this as root x plus 3. Okay? So notice now, once again, if I were to now graph this out, and some of you are having difficulties graphing it out, think back to chapter 3, or just make a table of values. X minus 3 is a parabola that looks like this, remember? But because I only want one side of it, the side that's bigger than 3, I guess I should only graph out the side that is over here. Okay, so I'm going to draw this in black if I can. And I apologize that I didn't give you enough space, or I should have given you a different graph. But there's your half of a parabola. And then if I asked you to find the inverse, what would you do with the inverse? Well, here we go. It's root x plus 3. So I guess that means I move up 3. And then I just kind of draw something like this over here. And I hope you can see that the black and the red are just mirror images of each other, or it's a reflection in this line y equals to x. Okay? So once again, the whole idea about doing this inverse stuff is to show you that the square graph, the quadratic graph, and this square root one are related to each other. Okay? So not that hard, I don't think, right? Just apply the same principle and try. Don't be afraid of making mistakes, okay? I think some of you are afraid of, oh, I don't want to do this, so I'm going to wait, and I'm just going to wait to see what the right answer is. You're not going to learn as much unless you try, okay? Last one here. I said, how are the transformation of f and x, or f of x, related to the transformations of the inverse? Well, once again, remember the inverse is just a reflection. These are all just reflections in which line? Well, it's in the line y equals to x. Okay? That's all we're doing here. Now, let's move on to the next page, because I've got this investigation for you. And I think we've seen something like this before. But if you're not too sure what we can do, I will once again ask you to make a table of values. Okay, we'll make one for root x. We'll make one for 3 root x. Okay, half root x. And also negative 3 root x. Okay? Can someone give me a suggestion of easy values of x to choose? What are some nice easy values of x? 0, yeah. What's the next one? 1, yeah. What else? 4 and 9. Sure, let's stick with those. Okay? So why don't you go ahead and take those x values, go ahead and figure out the corresponding y values for the first equation, then the next one, then after that, and graph them out. And let's see what happens here when I change the number that's in front of the x or the root x. Okay? Once again, I hope you remember this stuff from chapter 3 because you did all that before too. Okay? It's just a similar idea. Okay, and if you think about the first column, I think that's the easy one. 0, 1, 2, 3, right? That's just a regular graph. Regular chips. Emily thinks they taste good. Do they taste good? Sure. Okay. And I'm curious, what do you think happens with the one that's to the right of that? Y equals to 3 root x. That means I take all the values and multiply it by 3. What's 0 times 3? That's 0. What's 1 times 3? 3. 6, 9. Right, good. So go ahead and actually put those on there. 0, 3. Whoa, this is crazy. 2 is the same, sorry, 4 is the same thing as 6. 9 is also 9. Whoa. Okay. I'll try to color code this for you. Okay. And then think about what happens to the next one when I take all those values and I multiply by a half, right? So 0, 0 0.5 or a half, yeah. 1, thank you. And Johnson, what's the last one? 1.5 or 3 over 2. Excellent. So 0, 0, 1 and a half, 2 comma 1, 9 comma 3 over 2, graph. And the last one, notice it's very similar to the one in blue. The only thing that is different there is the negative x. Thank you. So because it's negative, it's dark. I'll make it black. 0, negative 3. Okay. Give you a chance to sketch those out yourself if you haven't done so already. And then I'm going to ask you to talk about this next part, and I'm going to actually show you some technical terms here, okay? So these are technical terms that you'll need for grade 12, okay? The technical terms are not fat and thin, by the way. Okay. Ladies and gentlemen, when the value, which I call a, which is in front of the root x, is bigger than 1, okay? So this absolute value means ignore the sign, okay? Ignore the positive or negative sign, okay? Just the number. If it's bigger than 1, do you see what happened to our graph? we went from the one that was red and it became blue. So for those ladies who have a hair tie, remember I did that hair tie last time? I did this. Whee! Yeah, I brought your hair tie. Yeah, so what am I doing? I'm stretching it which way? Vertical. So this is what we call a vertical expansion. Okay, that's the technical term. And if I were to look at the A value and notice it's less than 1, so now I'm saying compare the red with the purple. I took that hair tie and I went squished it. So that's still something that's vertical, but instead of expansion, what word do you think I could use here? Any ideas? You don't know? Compression. Contractions? Maybe. We're not giving birth here. You can't see? My scribble? Oh, my scribble says ignore. Ignore the plus and minus sign. That's what that absolute value sign means, okay? Now, there is that last one in black that had a negative in it. So what happens when I put a negative? It goes positive? What? It got switched to below. So really what we've actually done is we've taken that blue graph and we've reflected it in which axis?
On that x.
In the x-axis. So I'll say this. If a is less than 0, the graph is a reflection. And this is a reflection in the x-axis. Okay? You're reflecting it in the x-axis. And once again, you're thinking, well, Mr. Lee, we did all this before. Yeah, you did. You did it with the parabola. Now we're doing it with the actual square root graph. Okay? So what I'd like us to try next, and I probably won't be able to finish everything today, is let's take a look at example number 5. I'd like you to graph the following radical functions by identifying what type of transformations occurred. So what I'm saying to you here is by looking at the numbers, can you tell me how this compares with the regular graph? Okay, so here's our spicy bag of chips with all the different flavors. How does it compare with our regular bag of chips, which is just plain, plain, plain? Okay, so plain is this, right, root x. The spicy flavors are the 4 in the front and the x minus 2. So what does the 4 in the front represent?
Vertical expansion.
Good. And I'll say this, vertical, and write this down please. Vertical expansion. Okay. And I'll say by a factor of 4. Good. So stretch it 4 times as much. That's normal. Okay. Any other flavors I put in here?
Oh, negative.
The negative 2. Okay, so what does that mean?
Right.
2 to the right. Excellent. So this means now I go 2 to the right. Okay. Now, you can graph this out by making a table of values. Okay, and we can do that. So I'll just quickly use the table of values. Okay. What's the first value of x I should choose in this case? 0, 1, 2. Right. 2, and then I guess I'll do 2, and then I'll do 3. What else can I try? I want some nice numbers for you, right? You like nice numbers? So how about 6? And then how about 11? Okay? So why don't you go plug them into your equation and graph this out, and then hopefully I'll show you how those two spices give you your new graph. Okay? So graph this out, please. 2 minus 2 is 0, square root of 0 is 0, 4 times 0 is 0. 3 minus 2 is 1, the square root of 1 is 1, 1 times 4 is 4. 6 minus 2 is 4, square root of 4 is 2, 2 times 4 is 8. And I think the last one, 11, 11 minus 2 is 9, square root of 9 is 3, 3 times 4 is 12. You probably won't even see that one on your grid. I made a mistake there, didn't I? I should be plotting 2, 0, yeah. 3, 4, 6, 8. Okay. Okay, So I'll give you a chance to graph it out. And by the way, can you tell me what the domain and range is? I asked you for that too. Domain is, range is. Someone help me out. What's the domain? Look at the picture. What's the domain? Great. Greater or equal to 2. How about the range? Same thing? Well, first of all, it should be y, right? So is it y greater than or equal to 2? Are you saying it starts here at 2 and it goes up only? 0. Right. So be careful. Y must be bigger or equal to 0. Okay? Now, ladies and gentlemen, just before you go on to the next one, I'm going to let you try that on your own. Let me just show you how these two pieces of information play into getting this graph in black. Okay? Just watch. You don't need to write this down. If you want to, you can, but you don't have to. If I started with y equals root x, here's my graph. Okay? Now, what did I actually do? I said expand this by a factor of 4. So if I expand this by a factor of 4, instead of having it at 1, 1, where's the new coordinate going to be? It's going to be at 1, 4. Instead of having it at 4, 2, I'm going to expand the y value by a factor of 4. So 2 times 4 is 8. So hopefully you see this. So really what I've done here is I've changed the green to become the blue when I have an expansion by a factor of 4. Is that okay? So that was my first spice. There's the ketchup. Okay. And then what's the next thing I did? To the right. So I took the one in blue and I shifted them all to the right. So there's my mustard, according to Alex. I don't know why you like mustard and ketchup chips, but there you go. Okay? So that's how you can actually look at these transformations and get the final graph. Okay? Here's what I'd like you to do then, please. Okay, and I'll let you finish this one right now on your own. Can you try to at least identify for me the things that have happened here? And I'll tell you there are 3 of them. Okay? And then there are 3 spices, 3 flavors, 3 flavor chips. Okay? There should be 3. And then I'd like you to find domain and range if you could, and also graph. Okay? So let's try this, please. Okay? And then after that, I think I will probably finish the rest of this booklet after the break, since your next week is all test. What are the 3 transformations here? Can someone list one of them for me? Reflection. Yes, that negative represents a reflection in the x-axis. Good. Next. That 1/2, sure, is a what? Vertical compression. Okay. By 1/2. And then, yes, the last one is 3 to the left. Good. So don't forget, this is the one that's kind of weird. You see a plus, but it actually means minus. Go left 3. Okay? Now, ladies and gentlemen, watch as I sketch this out in less than 30 seconds. Okay? You timing me?
Ready, set, go.
Okay, go. Here's the original, right? 1, 4, 2, 9. Original. Shh. Okay, then where do I find the dots? Just make a table of values, right? Hey, don't slow me down. Okay, anyways, 0, 1, 2, 3. Now, a reflection in the x-axis, that means I just go down here, right? Reflect. Whee! A vertical compression, make it squishier. So let's cut it in half. Whee! Left 3. Oh, just move it 3 to the left. So starting 0, start here. Done. How many seconds? Time. Yeah, whatever. 32 seconds. I don't know. Anyways, domain, please. What's the domain? Greater or equal to? 3. What's the range? Yes, less than or equal to? 0.